graphing quadratic and absolute value inequalities, two variables, okay? So graphing quadratic and absolute value inequalities. And I'm going to put in parentheses two variables. So we're going to have an X and a Y. So a couple things I'm just going to jot down for us is no matter what type of graph, whether it's a line like from integrated one or these parabolas or absolute value graphs, if you have Y is greater or Y is greater than or equal to. For the Y is greater, this is going to be dashed or dotted, okay, dashed and shade above. Because greater means I want Y's higher than my graph. The Y is greater than or equal to is going to be a solid, I don't want to say line because these are going to be some of them curves, curve or line. And again, we're going to shade above. Now, if I have Y is less than or Y is less than or equal to, what's going to happen for this is, again, the Y less than is going to be dashed. The Y less than or equal to is going to be solid. But both of them, whether it's less or less than or equal to, you're going to shade below. Shade below your graph. Okay, you're going to shade below. So first example, I'm going to give us as a parabola. Y is greater than the quantity x plus 4 squared minus 3. So I'm going to graph this, okay? And what I want us to notice is this is going to mean that it is going to be dashed. And I'm going to shade above because I want Y's that are higher than my graph, okay? So let me draw my graph here. For this, my vertex is going to be -4, -3. So I'm going to go 1, 2, 3, 4, 1, 2, 3. This is a regular parabola. So from here, I'm really going to be going out 1 squared is 1. Out 2 squared is 4. 1, 2, 3, 4. Let me just go out one more. Out 1, 2, 3. 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So again, I started at -4, -3. 1 squared is 1. 2 squared is 1, 2, 3, 4. 3 squared is 9. And then I'm going to draw this, and I'm going to draw this as a dashed line or dashed curve, because the values on my parabola would make it equal. I don't want y's equal, I want y's higher. So if I have y's less than or equal to the opposite value of, or sorry, 3/4 times the opposite value of x plus 1 minus 2. For this one, again, I want to find my vertex. I find my vertex the same way I did for the parabola. What makes this 0? -1, comma, -2. So I'm going to go to -1, -2. Now, in this case, if I am looking at this is telling me that I'm going to be having a solid line, and less than or equal to, I'm going to shade below. That's what that's telling me. So for this, when I'm graphing this, since this is an absolute value, I can think of this stretch more like a slope. So I'm really going to go up 1, 2, 3, out 1, 2, 3, 4. Up 1, 2, 3, out 1, 2, 3, 4, and so on. Okay, and just keep going up 3 over 4. I'm running out of space here, so I'm just going to draw it here. So then I'm going to draw my line, and this line is going to be a solid line. So, whoops. How about I actually use a line instead of me trying to draw the line? Okay. So I'm going to have this and this. And again, these go forever and ever and ever. So let me put an arrow. Okay. And then in this case, I want less than. So if I come to my vertex, this is going to be less than. So I'm going to be shading everything outside, but outside is really below in this case. And that's going to be my answer.